All right, I'll start over on number 7. What pressure would be needed to fit 35 grams of N2 gas, so 35.0 grams of nitrogen gas into a volume of 195 milliliters, which equals 0.195 liters, at a temperature of 0 degrees C, which is 273 K. Now, in order to figure out the pressure, we don't need grams of nitrogen gas, we need moles. So I need to change this into moles. And I just got this off my periodic table. Now, because I don't want to round, I'm actually going to use this fraction in the equation so I don't lose any decimal places. So PV equals nRT, and we want to solve for pressure. So we're going to use, we have liters, Kelvin, moles. So our R was 0.0821. It's going back for a second. Liters, atmospheres, moles, degrees K. Right? All right, so our answer will come out in atmospheres, but let's put the, okay, so we have the, whoops, I put R first, no big deal. All right, let me put the moles now. 35.0 divided by this, that's my moles, isn't it, of nitrogen gas. My temperature is 273. I'm dividing by my volume, which is 0.195 liters. So let's put that into our calculator. 0.0821 times this fraction, I'll just put it in parentheses. Alright, so moles them times 273 and divided by 0.195. Alright. I'm going to worry about sig figs in just one moment. I'm going to write some of these down. So this is atmospheres, isn't it? Wow. It's a lot of atmospheres. Got to make sure I did that right. Yeah, that looks about right. We're dividing by this small number, which is going to make this go up. All right, it looks like we would use 3 sig figs, and in that case, this would be 144 atmospheres. Let's look at number 8. In order to have 1 mole of gas fit in a box that measures that by that by that at 1 atmosphere, thinking that's what it says, it was cut off, what must the temperature be in degrees C? All right, well, we got to figure out the volume, don't we? We have a box and a decimeter. A decimeter is 1/10 of a meter, isn't it? And what we do know, and he told us, oops, 1 liter. Oh, okay, he gave us a nice conversion there. Because I usually say 1 milliliter equals 1 centimeter cube, but we can use decimeters, that's nice. So our volume is 1.30, 2.40, 5.83. Length times width times height. Height, right? 1.3 times 2.4 times 5.83. Now I'm going to carry all the decimals. I don't want anything to... So if these are decimeters cubed, they're also liters, aren't they? So there's my liters, so my volume. And the N is 1 mole of gas. My pressure looks like 1 atmosphere, I hope it is. And we want to solve for temperature. PV equals nRT. So to get T, I have to divide by N and R, don't I? So it's going to be the pressure times the volume over the number of moles, which was 1. That's 1 atmosphere, isn't it? And the R, 0.0821 liters times atmospheres moles. Okay. Atmospheres, liters, moles, and okay. So 1 times 18.1896 divided by 1 divided by 0.0821 equals 221, just carrying more than I should, Kelvin. And if we subtract 273 minus 273, we are actually going to be negative. Let's check our sig figs. I think we can use 3. 51.4 degrees C. I think that seems right. Let's do one more calculation. 18 divided by 1 divided by 0.0821. Yeah, 221K. Subtract 273 to get negative 51.4 C. All right. Now going back to this, if this is a different atmosphere number, different number of atmospheres besides 1, then just change it in this calculation. All right. All right. Now it says a cube-shaped box is to be made that can hold precisely 40 grams of helium. Blah blah blah. Right. So remember, cube. So length, width, and height are all the same, aren't they, for a cube? So they're saying take the cube root of that volume. So let's look. We're going to solve for volume. PV equals nRT. So we want to use 40 grams of helium. No, we want to use moles, don't we? So if I look at helium, my periodic table, it's 4 grams in 1 mole. 40 divided by 4, right, should be our 10 moles. So we'll use 10 moles as our N. Our pressure is 1.05 atmospheres. The temperature got cut off here. So I will just use a temperature. Let's say we want the temperature to be 0 degrees C. All right, so that's 273 degrees K, isn't it? So let's see what we get. Volume equals N, 10 moles, R, 0.0821, temperature, 273 K. Liters, atmospheres, mole, K. So the K and the mole drop, and I'm dividing by the pressure, 0.05. Atmospheres will give me liters, won't it? So 10 moles, 0.0821 times 273 divided by 1.05. 213.46 liters, which we saw in the last problem was 213.46 decimeters cubed. So if we take the cube root of this number, so I'm going to raise it to the 1 divided by 3. That means each side is 5.9764 decimeters. Now, how many sig figs? Looks like 3. This will make, so 5.98 decimeters. If you need to change the temperature, do that and recalculate, since I didn't have the temperature there. Okay, let's look at the last one. What volume would be occupied by 16.0 grams of methane gas at 0 degrees C and 1 atmosphere? Now it's at STP, right? STP says that at STP, 1 mole of gas is 22.4 liters, right? So since it's at STP, I will first calculate to get moles, and then I'll say 1 mole is 22.4 liters. So let's look at, if carbon is 12.01, and I'm going to add 4.04 for those, methane should be 16.05 grams. We basically have 1 mole here, don't we? So and with 3 sig figs, it looks like 22.3 liters of CH4. Now, I can't read what this says here, but I think it says it's at STP, right? 0 degrees C and 1 atmosphere. We can simply use this conversion that we know. Okay? Now, let's just remember PV equals nRT. We want to write down everything we know and get it in the proper format based on the R we have here, right? So this would be liters, atmospheres, mole, degree K. And then I think the other one, which was way back at the beginning, still works with moles and K, but has kilopascals as our pressure. So use the appropriate one. And do not round inside the calculation. You noticed how I carried along some fractions where we had, I don't remember, 35 grams of something, and 28.02 was it the grams per mole. So this number here represented the moles of whatever that compound was. But as if I carry that along, then I haven't approximated anything yet. Do not round or approximate within the calculation. That way when you get to the end and you do the sig figs, you will get the same number as the teacher. All right, so take a look at these and let me know any questions. Thanks.